This video is a walkthrough of the November 2017 higher tier paper 1. Okay, question 1. Write 36 as a product of its prime factors. So that means breaking 36 down until we've only got prime numbers. So any two numbers that multiply to make 36 to start off with. If you 2 18s, 2 is prime. And then break down 18. So 2 9s. And then break down 9 into 3 3s. It doesn't matter what numbers you pick. If you picked 4 times 9 to start with, you would have still broken it down to the same numbers in the end. So we've got 2 times 2 times 3 times 3, and that is 36 as a product of its prime factors. So we just write on the answer line 2 times 2 times 3 times 3. Question 2. Chiara is 7 years older than Jay. Martha is twice as old as Chiara, and the sum of their 3 ages is 77. So we need to, write a ratio of Jay's age to Chiara's age to Martha's age, but we need to work out what their ages are. So we've got this information here, and we can form equations with it. So K is 7 years older than J. So K minus 7 is equal to J. Martha is twice as old as K. M is twice as old as K. So M is equal to 2 Ks. And the sum of their 3 ages is 77. So K plus J plus M is equal to 77. So what we're going to do is we're going to substitute. Instead of J, we're going to write K minus 7. And instead of M, we're going to write 2K. So we're going to have an equation in terms of K, and then that will tell us what K is when we solve it. So that's K plus, instead of J, K minus 7, plus M, which is 2K, equals 77. So collecting like terms, we've got K plus 2K, that's 4Ks, minus 7 equals 77. We're going to plus 7 to both sides, which is 84, and then divide both sides by 4, so we've got K equals 21. So we know K's age is 21, so K is 21. J is K minus 7, so 21 minus 7, 14. And M is 2 Ks, which is 2 21s, 42. So the ratio of J's age to K's age to M's age. So we've got 14 to 21 to 42. We don't need to simplify it, so we'll give this as our answer. Okay, question 3. So we've got a diagram here with all of the relevant information on it. It's also written in the text here. So ABCD is a parallelogram. EDC is a straight line. F is the point on AD such that BFE is a straight line. And angle EFD is 35 degrees. And angle DCB is 75 degrees. All of that information is already shown on the diagram. Show that angle ABF is 70. So ABF, we need to show that this angle here is 70 degrees. And we've got to give a reason for each stage of our working. So we can say that angle AFB is 35 degrees. AFB equals 35 degrees, and the reason is vertically opposite angles are equal. vertically opposite angles are equal. We can say that BAF is 75 degrees because opposite angles in a parallelogram are equal. So we've got 75 degrees, and then we've got a triangle here, and angles in a triangle add up to 180. So ABF, which is what we were working out, is equal to 70 degrees because 180 take away 75 and take away 35 is 70. And the reason we can do that is because angles in a triangle sum to 180 degrees. Question 4. The diagram shows a logo made from 3 circles. So we've got 3 circles, small circles got a radius of 4. We've got a medium circle with a radius of 4 plus 3, so 7. And we have the big circle, the whole logo, with a radius of 4 plus 3 plus 3, 10 centimeters. Each circle has center O. Daisy says that exactly 1/3 of the logo is shaded. Is Daisy correct? So we need to work out the shaded area and the total area and then express it as a fraction. So we're going to need to work out the area of each of the circles. So if we do the big circle, area is pi times the radius squared. For the big circle, the radius is 10. So it's pi times 10 squared, which is 100 pi centimeters squared. We're going to leave it in terms of pi because we don't have a calculator. The medium circle, middle circle, again, area is pi times the radius squared. The radius this time is 7. So pi times 7 squared. 7 and 7's are 49. So the area is 49 pi centimeters squared. And finally the smallest circle. It's got a radius of 4. So the area is pi times 4 squared this time, which is 16 pi centimeters squared. So there's the areas of all the circles. Now the shaded area is the middle circle take away the little circle. So 49 pi take away 16 pi, and that is 49 take away 16, 33 pi centimeters squared. So the shaded area is 33 out of the total area of 100. So 33 pi out of 100 pi. You can cancel the pi's, and that's 33 100ths. So the shaded area is 33 100ths of the whole area. Is that exactly 1/3? No. So 33/100 is not equal to 1/3. It's not exactly equal to 1/3. It's quite close, but it's not exactly equal to 1/3. So Daisy is not correct. Okay, question 5. The table shows information about the weekly earnings of 20 people who work in a shop. So we've got the information in the table, and part A says work out an estimate for the mean of the weekly earnings. So we need to estimate the mean. So we need to add up all of the weekly earnings of all the people, but we don't know what they actually earned. We know this one person earned somewhere between 150 and 250. These 11 people earned something between 250 and 350. So as an estimate, we used a midpoint. So we're going to say this person earned the middle, which is £200. We're going to say these 11 people earned the middle, so 300. So we're going to write down all the midpoints. Then we're going to times how many people by the amount of money. So 1 200 is 200. 11 300s is 3,300. 5 400s is 2,000. Nothing times 500 is nothing. And 3 600s is 1,800. So adding all these up, so we get the total amount of money earned by all the people, all 20 people. So 0, 0, 2 plus 3 plus 8 is 13. 3 plus 2 plus 1 plus 1 is 7. So we've got 7,300 divided by 20 people. So 730 divided by 2. So £365. Okay, part B. Nadia says the mean may not be the best average to use to represent this information. Do you agree with Nadia? You must justify your answer. So the reason we wouldn't use the mean is because the mean is affected by extreme values. If we have outliers, if we have really big numbers, they will drag the mean up. So they make it a less useful number. So we could make the argument that these 3 people are outliers. They are extreme values that have increased the mean. So it may be more useful to use the median. So do you agree with Nadia? Yes. And we just have to put the mean is affected by extreme values. Okay, question 6. Here is a rectangle. All measurements are in centimeters. The area of the rectangle is 48 centimeters squared. Show that y equals 3. So the first step is to find out what x is. And we can do that because we know that the 2 opposite lengths of a rectangle are equal. So we can work out what x is because 2x plus 6 must be equal to 5x minus 9. So we're just going to solve this equation. So we're going to subtract 2x from both sides, which leaves us with 6 equals 3x minus 9. Then we're going to get x by itself. So we're going to plus 9 to both sides, which leaves us with 15 equals 3x. Divide both sides by 3. X equals 5. So we know x is 5. So that should tell us the length. So 2 5s plus 6, 10 plus 6, 16. And we can do the same on the other side. 5 5s, 25, minus 9, 16. So we know the length is 16. The area is 48, so 16 times y equals 48. 16y equals 48. Divide both sides by 16. Y equals 3. And that's what we had to show. Question 7. Brogan needs to draw the graph of y equals x squared plus 1. Here is her graph. So she's drawn the graph. The question is, write down one thing wrong with Brogan's graph. The problem is she's used straight lines when she should have drawn a curve. So she used straight lines. She should have drawn a curve. Okay, question 8. Write these numbers in order of size. Start with the smallest number. So we've got 0.2464646. We've got 0.2466666, 0.246246, and we've got 0.246. So start with the smallest number, which is the smallest number. That's 0.246. Then what's the next digit? So the next smallest digit is a 2. So we've got 0.246 all recurring. Then we've got a 4 on this one. 0.24646. And finally 0.246 recurring. Question 9. James and Peter cycled along the same 50-kilometre route. James took 2.5 hours to cycle the 50 kilometres. Peter started to cycle 5 minutes after James started, and he caught up with James when they both cycled 15 kilometres. James and Peter both cycled at constant speeds. Work out Peter's speed. Okay. So James took 2.5 hours to cycle 50 kilometers. So we can work out James's speed. Speed is distance over time. So if we do James, for James, his speed, so speed is equal to the distance, which is 50, over time, which is 2.5. For double top and bottom, that's 100 over 5, which is 20 kilometers per hour. So that's James's speed. And Peter caught up with James when they'd cycled 15 kilometers. So we can work out that time, can't we? So time is distance over speed. So that's going to be 15 over 20, which is 0.75, but it's 3/4, probably put 3/4, because we're in hours, so that's 45 minutes, or 3/4 of an hour. So he caught him up after James had been cycling for 45 minutes, but Peter had only been cycling for 40 minutes because he started 5 minutes later. So Peter in 40 minutes cycled 15 kilometers. So if I change 40 minutes into 2/3 of an hour, 2/3 of an hour, so Peter's speed is that distance, 15, divided by 2/3. So 15 divided by 2/3. So that's, we'll just do 15 times 3/2. Dividing by 2/3 is the same as timesing by 3/2. So that's 45/2, which is 22.5 kilometers per hour. Okay, question 10. Write down the value of 100 to the power of a half. Power of a half just means square root. So square root 100 is 10. Part B. Find the value of 125 to the power of 2/3. So the 3 on the bottom, the third, is a cube root. And the 2 on top means square. So we're going to cube root and square 125. So cube root 125, that's what number times itself again makes 125. That's 5. And we still need to square it. 5 squared is 25. Okay, question 11. So we've got a simultaneous equation hidden in words. So 3 teas and 2 coffees. 3 teas and 2 coffees have a total cost of, I'll put 780, so I'll do it in pence. Have a total cost of 780. And 5 teas and 4 coffees have a total cost of 1,420. So we need to work out how much a tea and coffee cost. So we need to make either the T's the same or the C's the same. I think it's going to be easier to make the C's the same. Usually I make T's the same, but this time I'm going to make the C's the same because it's easier. It doesn't matter if you make T's the same, you've just got harder multiplications to do. So I'm going to times the top one by 2, which is going to give me 6 T's plus 4 C's equals, so 2 780s. 2 700s is 1,400. 2 80s is 160. So that's 1,560. So I'm going to take these away now. I'm going to do the red one, take away the blue one. So 6 T's take away 5 T's is 1 T. 4 C's take away 4 C's is nothing. And 1,560 take away 1,420. That is 140. So a T is 140 or £1.40. I'll write that in the answer. T is £1.40. And yeah, and I'm going to substitute that back in to find out a coffee. So if I substitute it back in to the top line, so I'll have 3 140s plus 2 C's equals 780. 3 140s, that will be 420 plus 2 C's equals 780. Take away 420 from both sides will leave us with 360, and half both sides will leave C as 180. So that means a coffee is £1.80. Okay, question 12. The table shows information about the heights in centimeters of a group of year 11 girls. So we need to draw a box plot. That's the question. Draw a box plot for this information. And what we need to draw a box plot is the lowest height, which we've got, the lower quartile, and the median. But we also need the upper quartile and the highest height. And we haven't been given those, but we've been given something that we can use to work them out. So for the upper quartile, we need the lower quartile plus the interquartile range. So 161 plus 7, that's 168. And for the highest height, that's going to be the lowest height plus the range. So 154 plus 20, 174. So there's all our information to draw the box plot. So now it's just a case of drawing it in. So we need a line at 154. One at 161. 165, 168, and 174. And then we join up the three middle ones in a box and add on the two whiskers. And there is our box plot. Okay, part B. So we've been given another box plot for the year 7 girls, and we need to compare the two distributions. So we need to compare the year 7 box plot with the year 11 box plot. So what comparisons do we make? We compare the median, so the measure of average, the median, and the measure of spread as the interquartile range. So if we look at the year 11 median, we see it's at 165. The year 7 median is at 157.5. So the year 11 girls are taller on average because they've got a higher median. So we'll write that in. Year 11 girls are taller on average and that's because they have a higher median height. Then we'll compare the interquartile range. So look at how spread out they are. So the year 11 interquartile range, that was 7. And the year 7 interquartile range, that's 10.5. So the year 7 heights are more spread out. So year 7 heights are more spread out as they have a higher interquartile range. Interquartile range. Okay, question 13. A factory makes 450 pies every day. The pies are either chicken pies or steak pies. Each day Milo takes a sample of 15 pies to check. The proportion of the pies in his sample that are chicken are the same as the proportion of the pies made that day that are chicken. So on Monday, he needed exactly 4 chicken pies. So his sample is 15 and 4 of them are chicken. So 4 15ths are chicken, and that's the same proportion. So 4/15 of 450, so 4/15 times 450 will give us how many chicken pies were made that day. So we want 4/15 of the total amount. So let's times across this. So this is 450 over 1. And we're going to times the top times the bottom. So 4 450s is 1,800. So we double it and double it again. And 15 times 1 is 15. So I can simplify this fraction. I can divide top and bottom by 3. So 18 over 3 is 6. So 600 over 5. 15 over 3 is 5. And then what's 600 divided by 5? 600 over 10 is 60. So double it, 120. So 120 chicken pies were made on Monday. Okay, on Tuesday, the number of steak pies Milo needs is 6 to the nearest whole number. So work out the lower bound of the probability that it's a steak pie. So the lower bound, if we've got 6 to the nearest whole number, so you've got 6 here, the one below is 5, the one above is 7, so the lower bound, we've got 5.5, and the upper bound, 6.5. So the lower bound is going to be using 5.5 out of 15. So 5.5 out of 15 pies, that's the lower bound. And I guess we want to double this, we don't want a decimal, so double the top, it's 11, double the bottom, 30. So the lower bound is 11/30ths. 11/30ths of the pies being steak is the lower bound. Okay, question 14. The ratio y plus x to y minus x is equivalent to k to 1. So I've got equivalent ratios. So when we've got equivalent ratios, that's like having 1 to 2, or 2 to 4, or 3 to 6. These are all equivalent ratios. And because they're equivalent, we could say left side over right side equals left side over right side equals left side over right side equals left side over right side. So where I've got equivalent ratios, that means the proportion's the same. So I can change this statement into y plus x over y minus x equals k over 1. And we're being asked to show that, well, we're getting y as a subject of the formula. So we need to rearrange this to give y as the subject of the formula. So I'm going to rewrite it without k over 1 as just k, because k divided by 1 is k. Then I'm going to multiply both sides by y minus x. I'm going to expand the bracket. So that's ky minus kx. Now I need to get the y's on the same side. So I'm going to plus kx to both sides. So I'll have y plus x plus kx equals ky. Going to subtract y from both sides. Now I'm going to factorize y out. So that'll give me y open bracket k minus 1. And divide both sides by k minus 1. So y equals x plus kx over k minus 1. That must be almost what we wanted. So we need to also factorize out the x. That's no problem. So if I move to here, factorize out the x, so that'd be 1 plus k over k minus 1. And that's what we wanted. Well, we wanted the 1 and the k the other way around. We can just rewrite that. K plus 1 over k minus 1. And there's our answer. Okay, question 15. So we've got x equals 0.436 recurring, so 0.4363636, and we need to convert it to a fraction, so prove algebraically that it can be written as 24/55. So we're going to start with our x equals 0.4363636, and we're going to get two things that end in 36, the recurring part. So if I multiply by 10, I get 10x equals 4.36 recurring. 4.363636. And if I multiply by 1,000, have 1,000 x's, that would be 436.36 recurring. Now I've got two things that end in the recurring part. I'm just going to take them away. So if I do the bottom one, the 1,000 take away the 10, 1,000x take away 10x is 990x, and 436.363636 take away 4.363636. The recurring part cancels, so I've just got 436 take away 4, which is 432. Now divide both sides by 990, and I've got 432 over 990. So I've converted it into a fraction, but we still need to simplify the fraction. So if we divide top and bottom by 9 or 3, so if I divide by 3, 3's into 4 go once with 1 remainder. 3's into 13 goes 4 times, 1 remainder. 3's into 12 is 4. So that's 144 over 330. I'm going to divide by 3 again. So 3 into 144 this time. 3 into 1 doesn't go. 3's into 14 goes 4 times with 2 remainder. 3's into 24 is 8. So 48 over 110. And then I just need to half the top and bottom for 24 out of 55. You probably would have got away with just writing the answer straight away after you've converted it to a fraction, but it's good to know we've done it correctly because we have actually got the answer. Okay, question 16. Y is directly proportional to the cube root of x when y equals 1 1/6, x equals 8. Find the value of y when x equals 64. So y is directly proportional, so that means y equals k times the cube root of x. And we've been given this information, so when y equals 1 1/6, x equals 8. So we're going to find out what k is using this information. So when y equals 1 1/6, I think I'm going to write that as 7/6. So when y equals 7/6, 7/6 equals k times the cube root of 8. So 7/6 is k times, what's the cube root of 8? That's 2. So 7/6 equals k times 2. So I'm going to divide both sides by 2. So that would be 7/12 equals k. So k is 7/12. So we've got our formula now. Y equals 7/12 times the cube root of x. Find the value of y when x equals 64. Y equals 7/12 times the cube root of 64. So 7/12, what's the cube root of 64? That's 4. So 7/12 times 4, and that will be 7/3. Because we've got 4 over 1 here, and I've cancelled the 4 with the 12. So 7/3, and that's our answer. So y equals 7/3. Okay, question 17. N is an integer. Prove algebraically that the sum of half n into n plus 1 and half n plus 1 n plus 2 is always a square number. So the sum of just means added together. So we've got half n into n plus 1 plus half n plus 1 times n plus 2. So all we've got to do is simplify this, and hopefully we should prove it's a square number. So if we expand all of the brackets, hopefully the reason it's a square number will be clear. So expand the bracket, so we've got half n squared plus half n plus, I'll leave the half here now and expand these two brackets. So n squared plus 2n plus n plus 2, which is half n squared plus half n plus half, and I've got n squared plus 3n plus 2, collecting the like terms. Then I'm going to expand the second bracket. So half n squared plus half n plus half n squared plus 3 over 2n plus 1. And again, collecting like terms. So I've got 1n squared now plus 2n plus 1. So I've simplified it. How can I prove it's a square number? Well, if I factorize this, so factorizing n squared plus 2n plus 1, what multiplies to make 1 and adds to make 2, that's 1 and 1, and that is n plus 1 squared. So it will always be a square number because it's an integer squared. Okay, question 18. Enlarge shape P by the scale factor -1/2, center enlargement at the origin. So scale factor -1/2 and label the image Q. Okay, so to get to the bottom corner, and color code it a little bit. So to get from the bottom corner at the moment, we go along 2, up 3. So along 2, up 3. And I'm going to times that by -1/2. So what does that give us? That will be, well, 2 times -1/2 is -1. 3 times -1/2 is -1.5. So back 1, down 1.5. So back 1, down 1.5. So instead of along 2, up 3, it's back 1, down 1.5 to the green coordinate. So let's have a red coordinate. So along 4, up 3, along 4, up 3, times -0.5. 4 times -1/2 is -2. 3 times -1/2 is -1.5. So back 2, down 1.5. Back 2, down 1.5. And we'll have a purple coordinate. So 2, 7 at the moment. Times it by -1/2. 2 times -1/2, -1. 7 times -1/2, -3.5. So back 1, down 3.5. So there's our triangle. We just need to join it up now. And we label it Q. Okay, question 19. So we've got a rectangle, ABCD. A, E, and B are all points on the line AEB. That's the line x plus 2y equals 12. A and D are on the line M. AE equals EB. AE, EB, okay. Find an equation for M. So an equation for this straight line, M. So what do we need to know? We need to know it's a rectangle. So we've got a 90-degree angle here. And M and L are perpendicular. So we can work out the gradient of M using that fact. And we'll be able to find out where this point is, where A is, using the y-intercept of this line, because it'll be, well, the distance here with the distance again. So we'll start with this line, x equals 2y, x plus 2y equals 12, and we'll make y the subject. So 2y equals negative x plus 12, subtracting x from both sides, and then we will half both sides, so negative half x plus 6. So we know the gradient of L equals -1/2. So because it's a perpendicular, the gradient of M is a negative reciprocal of -1/2. So flip it and change the sign, so that becomes 2. So the gradient of M equals 2. So we've got y equals 2x plus c. Now we don't know what c is, but we can work out where this coordinate A is. So the y-intercept of L, this blue line, this one, is 6. So this is 6. And if we work out where it crosses the x-axis as well, so it crosses the x when y equals 0. So if you look here, if y equals 0, x plus 2y equals 12, it crosses the x-axis when the y coordinate is 0. That will be x equals 2 zeros. X plus 2 zeros equals 12. So x equals 12. So this coordinate here is 12, 0. So I can work out the coordinates of A now. So if we go back 12, up 6, back 12, up 6, it's the same distance, that will get us to the coordinates. So back 12 to 0, back another 12, that'll be -12 on the x. Up 6, then up another 6, that's 12 on the y. So we know this line goes through negative 12, 12. So if it goes through negative 12, 12, x is negative 12, y is 12. So we can substitute these in and find c. So 12 equals 2 negative 12s plus c. 12 equals negative 24 plus c. Add 24 to both sides. C is 36. So the equation for m is y equals 2x plus 36. Okay, question 20. The table shows some values of x and y that satisfy the equation y equals a cos x plus b. Find the value of y when x equals 45. Okay, so we need to know what cos x equals normally. So if I write cos x under here, so sine cos, okay, so when cos cos 0, cos is root 4 over 2, which is 2 over 2, which is 1. At 30, it's root 3 over 2. At 45, it's root 2 over 2. At 45 is not there. At 60, it's root 1 over 2, which is a half. At 90, it's 0. So hopefully we've got enough information here to work out what a and b are. So y equals a cos x plus b. And if we take our first point, so when y is 3, cos x is 1, so 3 is a times 1, which is a plus b. And if we take, well, let's use 90, that's a nice number. So when y is 1, we've got a times cos x, which is a times 0, so that's 0, plus b. That'll give us b as 1. So if we know b is 1, we can substitute that into here. 3 equals a plus 1, so a must be 2. So the question says, find the value of y when x equals 45. So y equals a 2 times cos x plus 1. And cos 45 is root 2 over 2. So root 2 over 2 times 2 is root 2, and we've got plus 1. So y is root 2 plus 1. Okay, question 21. Show that 6 minus root 8 over root 2 minus 1 can be written in the form a plus b root 2, where a and b are integers. So I think the first thing I want to do here is I want to change root 8 into 2 root 2. So root 8 is root 4 root 2, which is 2 root 2's. So I'm going to change root 8 into 2 root 2's. And now we're doing something called rationalizing the denominator. So to get rid of the third on the bottom, I need to multiply the top and the bottom by root 2 plus 1. So just changing the sign. and that will get rid of the third. So if I expand these brackets, the third will disappear from the bottom, and that is what I want to do. So if I expand the bracket, so 6 times root 2 is 6 root 2. 6 ones are 6. Negative 2 root 2 times root 2 is, well, root 2 times root 2 is 2, and 2 times 2 is 4, so it's negative 4. And negative 2 root 2 times 1 is negative 2 root 2. And that's over. Root 2 times root 2 is 2. Root 2 times 1 is root 2. Negative 1 times root 2 is negative root 2. And negative 1 times positive 1 is negative 1. So now collecting the like terms, we've got 6 root 2 take away 2 root 2, which is 4 root 2. 6 take away 4, that's 2. And on the bottom, 2 take away 1 is 1. And root 2 take away root 2 is nothing. So the root 2 is cancelled. And that's the whole reason why we did this change of sign in the first place. So I've got 4 root 2 plus 2 over 1, which is 4 root 2 plus 2. So 4 root 2 plus 2, or I can write it the other way round as 2 plus 4 root 2. Question 22. The two triangles in the diagram are similar. So we've got two triangles drawn. We've got a little triangle and a big triangle, and we're told they're similar. There are two possible values for x, two possible values of x. Work out each of these values. State any assumptions you make in your working. So we've got the two similar triangles, but we don't know which side goes with which other side. We don't know which side is a multiple of which other side, and that's why there's two different values. So either side AE times the scale factor makes AD, or AE times the scale factor could make AC. So if, let's say AE equals K times AD. So let's say AE and AD, they're the sides that go together. So we'll have AE as 12 equals the scale factor times AD, which is 15. That will make the scale factor 12/15, or 4/5. So if the scale factor is 4/5, and that will mean AB goes with AC. So AB, which is 8, would equal 4/5 of AC. So I'm going to divide by the scale factor, or times by 5, say 40, divide by 4, that's 10. So then AC would equal 10, and that would make X 2. Now, if we did it differently and said AB goes with AD, so AB equals K times AD. AB is 8, AD is 15. That would make the scale factor 8/15. So then AE would go with AC. And AE is 12. So 12 equals 8/15 times AC. Times by 15. So 15 times 12 is 15 times 10 is 150, plus 2 more 15s, so 180, and divide by 8, 180 over 8, 90 over 4, 45 over 2, which is 22.5. So AC would be 22.5. Take off the 8 to give us X. So X would be 22.5. Take off the 8. 22.5. Take away 8. 14.5. Question 23. So we've got a triangle, a right angle triangle and a rectangle and a right angle triangle. And the area of the rectangle is bigger than the area of the triangle. So the area of the rectangle, that's base times height, is bigger, so is greater than the area of the triangle, which is half base times height. Find the set of possible values of x. So solve, basically. So expand the brackets, 3x times x, 3x squared. 3x times negative 1, negative 3x. Negative 2 times x, negative 2x. Negative 2 times negative 1, plus 2. And over this side, we've got half times 2. That's 1, and x times x, x squared. So if I get all the terms on the left, 3x squared take away x squared is 2x squared. Negative 3x take away 2x, negative 5x plus 2. So I'm going to factorize now. 2x in one bracket, x in the other. There's lots of different methods of factorizing these sorts of quadratics. I'm just going to go straight to the answer. So I've got 2x minus 1 and x minus 2. If I expand this, 2x squared minus 4x minus x plus 2, I'll get back to what I was factorizing. So what do I have? I've got, remember this is an inequality, so if it was equal to 0, I'll have x equals a half and x equals 2. But it's an inequality, so I want to know the points of the graph. So it crosses at half and 2. I want to know the parts of the graph bigger than 0. So where's it bigger than 0? That's above the x-axis. So x is less than half, or x is bigger than 2. Okay, now let's look at the measurements. I cannot have a negative value of x, and in fact it's going to have to be bigger than 1. So x is going to have to be bigger than 1, otherwise I'll have a negative length, which I can't have. So bearing that in mind, x is going to have to be bigger than 1, so I can't have x less than a half, so x is bigger than 2.